Okay, hello everyone. So today we will look at socket programming in C and Python. I will be talking only about Python programming, Python socket programming. There will be the equivalent C code on the slides for those of you who are familiar in C and C++. But I think learning in Python is a good idea for two reasons. First, because as you will see, it's easier. You will write less code to do the same thing in Python compared to C. And then because your first project is going to be on Python, so I think it's more relevant for you to learn this lecture in Python. So I'll talk through two things, the POSIX socket API for UDP and TCP. So this is an API like any other API that the libraries of your codes of choice, so Python and C, the socket libraries of those languages, will call. So Python socket library will call the POSIX socket API, and same for C. So we're going to look at the functions that you can call on this API to write client-side code and server-side code. And then we'll just talk about shortly about Netcat, which is a command line tool to easily deploy a client and a server. This will be particularly useful during the project for debugging purposes. So please pay attention to that. So as Professor talked about it, we have this client-server model. Most of the traffic today on the internet goes from one client to a server. You also have peer-to-peer models, so connections from clients to clients. We're going to look at the client-server model, where basically servers wait for requests coming over the network from clients. They process that request and then maybe send a response back. A good example is the web browser to web server relation, where you, the client with a web browser, might request, for example, index.php, and then the server will send you back the appropriate file so that you can see it on your browser. Any questions so far? Okay. So both server and client, in order to send those messages, those requests and those responses, have to use a socket. Okay? But what really is a socket? In practice, I like to see sockets, and I think the book also mentions it as doors. You as an end host, you are surrounded by four walls, and if you want to communicate with the outside world and in turn receive messages from the outside world, you need to have a door. So both clients and servers have to have sockets, and more formally, the socket is a tool for processes separated by a network to communicate. And from now on, I want you to think of the address of a socket as a tuple, which is comprised of an IP number and a port. So when we say socket's address, it's the IP number and the port for that socket. Now let's look at a UDP client and a UDP server, what they have to write. Okay, what code do they have to write on each end in order to be able to communicate between each other? So as I said, they both have to create their doors, right, in order to communicate. So they will both create a socket in order to send and receive UDP datagrams. And to do that, in Python, you only have to call the socket function, okay, with two arguments. I'll get to that. And it returns a socket. So the server does this. It will return the server's socket. As for the two arguments, the first arguments will just indicate the socket what address family it wants to use. So here, AF-INET corresponds to IPv4. You have other address families. I won't get into that, but you only have to think about using AF-INET for the first example because that is the addressing that is used in general. As for the second argument, which is sock-dgram, it indicates the protocol that you want to use. Okay, so sock-dgram corresponds to UDP. And you will see that there will be another keyword for TCP. So that is it. When you create your server, you just give the keyword, the second argument, and that will tell the socket which transport layer protocol to use. So now that the sockets have been created, both on the server and on the client, now the server has to call an additional thing called bind. So this will bind the listening socket to a specific port that should be known to a client. And so that is it in terms of preparing the sockets, okay? Then you can just send and receive messages, datagrams, between clients and servers. So let's look at a server, how it will expect a message from a client, okay? So the server socket will just do server socket.receive from with some buffer size. So this is a blocking call, a blocking function. It will wait until it receives a message. And the buffer size, if you wonder what that is, it's the maximum number of bytes that you will receive when you do one call of receive from. So if the message is longer than 2048 bytes, then you have to call receive from again. Okay? You have to have a while loop and wait until the end of the message. Here, for simplicity, let's just assume that the message that is received is smaller than that, so I'll just do one call, receive from. Whenever the function gets something, it will return the message and the client's address. Okay? And the client's address contains the client's IP number and its port. And so me as a server, I can process that message and then send a response message, a modified message, back to that client by calling server socket.sendTo the message for the first argument and the client's address for the second argument. And for the client side, you can imagine the same thing, just switch the orders of these two functions. You will first send client socket.sendTo my initial message to server address, and then I call my blocking receive from function where I'm expecting a response from the server. Okay? Now let's do a demo. So here I have my UDP client code and my UDP server code. So I will instantiate one client and one server on the same machine. Okay? So as server name, I can simply pass localhost because my server is on my machine. If it was on someone else's machine, you will have to indicate that and host IP address. But here, for simplicity reasons, I will just put localhost because I have my server over here. The server port has been agreed upon beforehand, so we know that in both cases it will be 12, the server will listen to 12 000. And then I just create my socket as we discussed, which will return the client socket. I will have a message that I will just type in during the demo, and that message will be sent to the server. And then I write my receive from my blocking function so that whenever the server responds, I get my response message with the server's address, and I will just print that back, okay? And whenever I'm done with what I have to do on the client side, always make sure to close the socket. On the server side, so we have the server ports, the socket that is created. One extra thing that the server has to do, remember, is to bind. Here I'm expecting connections from anyone. I could have said connections from localhost as well, if I just expect this client to send stuff. And then I enter this while true loop. This is because you don't want the server to receive one message, process it, send a response, and then close. By definition, a server has to wait for queries from anyone and then process them, respond, and then wait for others. So it's a continuous loop, all right? And then within this while loop, I receive first, process the message. This processing can be anything. Here, for simplicity reasons, I will just put everything to uppercase characters, the message that I receive, and then I will send it back, okay? Any questions for the code? Yes?
When you call bind in the server socket, could you do localhost too, since we expect, like in this particular example, the client is...
Yep. You can only put localhost and it will work as well. So Python, UDP server. Okay, so the server is ready to receive. Client. Okay, so input sentence, hello world. I press enter. The server handled that client with this port who sent this message, and it sent back a pretty aggressive hello world. So What do you think about this? Yes.
If you go back to UDP clients,
Yes.
why do you not need a loop to like continually receive messages from the server?
Because I assume that the message that is received only is like 2048 bytes long at most, just for the sake of the example. But you can also, the good way to do it, if you don't know the size of the message that you will receive, is to have a while loop and then wait for a message terminator character that will say this was the last message sent, okay? And this terminator could be, a new line. You'll see in HTTP that you will have to look at these things. But next week, Professor will talk more about that. So I did specify a port for the socket of the server. However, I didn't specify any ports for the client's socket. But we see that we have this port number on the client side. How was this determined? Any guesses? So what the OS does when you don't specify a port, it will simply randomly choose an available port. And in this case, for the client side, this port turned out to be an available one, so it associated to the client side socket. As simple as that. Okay, now for TCP. You'll see that it's a little more complicated in the beginning, but it's as simple in the execution when sending and receiving messages. So once again, you have to create those doors in order to communicate. So create your sockets in both ends. Only difference is that here, instead of sock dgram, you have to write sock stream, which is for TCP. And then bind, which is exactly the same as UDP, okay? Server socket dot bind. Now an extra step on the server side is to put your socket in listening mode. So you have to say server socket dot listen, so it will listen to connection requests by clients. Okay, this is very important, otherwise your code won't work at all. Server socket dot listen, and the max pending variable, just set it to 1, okay, even for your project. What it means is it's the number of queued connection requests that the packet will handle, will buffer until it drops them. So if you say 2, then if you receive 2 simultaneous connection requests, the second one will be just queued before it can be processed. You can just set that to 1. Don't really think too much about that. So now that my server is in listening mode, so very important. This is very important. Now on the server, I have a listening socket, okay? Remember this. I'll get back to it. Now the client wants to connect, okay? What it will do is it will simply call client socket.connect with the server's name, so the server's IP number, okay? And the server's port. Any questions so far? Yes.
So the client itself calls client socket.connect?
Yes. You have a socket on the client side to send information and send connection requests, and then you have a socket on the server side to accept connection requests. You have 2 different sockets. Okay? So now the server has to accept that connection, so it will call server socket.accept. This is a blocking function, just like receive. It will wait until a connection request is sent, okay? And then whenever that is done, it will create a new socket called the connection socket. So now you have another socket called connection socket. And it is completely different from the listening socket that you had in the beginning, okay? Those are 2 different things. The connection socket is a socket that has been created exclusively for interaction between the client who sent that connection request and me, the server. If another client wants to connect, then another connection socket will be created. And this ensures that anything that is sent through that socket will go only to that client, okay? And anything that comes in turn to that connection socket, you will know that it only comes from that client, okay? And I think this explains what is going on pretty well. You have the connection request on the client side, the listening socket that will accept that request and create a new socket, and all further communication between the client and the server will be done through the new connection socket on the server side. Okay? Any questions? Yeah.
What about for certain like multitask?
Do you mean like multiple?
Like yeah, like if the server is just gonna send out something on its network to maybe like a prefix of clients instead of just one.
So you have to have a connection established with a client beforehand, and you can handle multiple of them. You can handle multiple clients at once by doing threading, for example, okay, parallel threading, and you can send your message to all of them through all these different sockets, okay? But that is one step further. For now, let's just keep it simple and just assume that we have just one client connecting, okay, and this connection socket, all right? That's it. And now that the connection socket has been created, we can safely send and receive packets between client and server. And as you will see, it's very similar to UDP in terms of how it's laid out. You will have connection socket.receive with some buffer size. Notice that here, you only receive the message. You don't receive the client address. Why is that? Exactly, because the connection socket is specific to that client. You know who sent it. And then connection socket.send, your response message. You don't have to specify any address because you know who you're sending it to, okay? Okay, demo time for the TCP client and server. Now I have my TCP client. Same as before, I have a local host for the server name, the server ports, okay? By the way, I see that you're taking pictures. I will upload all of these to Piazza. All this code to Piazza, all right? So, okay, I create my socket, my client socket. I connect the server from this line, okay, line 8 onwards. I can assume that the connection has been established. So whatever I send through this client will go to this server, okay? So I have my sentence, and I send it just to the server without specifying any server address or anything, okay? Then I will call my blocking receive function, which will return a response. And then I'll just, for debugging purposes, print the response and close my socket. On the server side, I have the ports, the socket that is created. Beware, listening socket. It will bind, listen, and then when I enter this while loop, here the first line will accept a connection request, okay? It will block there, wait for a connection request. Whenever it has been established, it returns my new socket, and then I will use this socket to receive the message and then to send back a message. And when I'm done, I close it. Okay? Any questions?
What's the meaning of listen parentheses one?
Pardon me?
What's the meaning of listen parentheses one?
In listen?
Yeah, the number of one, what does it mean?
So the one, it means the number of queued connection requests that you will keep in buffer before dropping them. So if you receive 2 or like 3 connection requests at the same time, then since I indicated 1, so 1 will be received, 1 will be buffered, and the third will be dropped. If I indicate 2, then both 2 would be just kept so that, you know, whenever I call accept again, it would feed in the second connection. I accept again, it will feed in the third connection, okay? Yes?
Could you explain again what the parameters are in the socket method? Or the
Sure. Yeah. So the first, it indicates the address family, AF INET. That is, so AF INET is, since we have a little time, I will go through it. But really, you don't have to think too much about it. Just write AFINet. This will just tell the socket that the addressing type will be the IPv4 type, which is the 32 bits addresses that you are used to see, like 1.1.1.1. Those are each 8-bit numbers, so it adds up to 32 bits. You have another family called the IPv6, which is 64-bit addresses, but here we'll just use IPv4, so just indicate AFINet, okay? And for the second argument, which is sockstream, it indicates the protocol that you want to use. Sockstream is for TCP, and sockdgram is for UDP, okay? Okay, now Python TCP client, hello world. Once again, it has handled this with this person, which is, by the way, this IP address is equivalent to localhost. It's the same thing. It literally means the same thing. A port that has been randomly assigned to the client, and then it sent hello world, and it got back hello world. Any questions? Yes?
The message exceeds the buffer size, will it drop the message? Or
No. So if it exceeds, okay, we can maybe, Let's say my size is 8, okay? Now I will have to do a while loop over here, where I will have to basically continuously receive all the chunks, because they will not be dropped. They will still be kept in the buffer. It's just that you're receiving 2048 bytes in one call. If it's bigger, you have to call it again, call it again, call it again. And if you ask me, when should I stop? Well, you have to wait for this terminator character at the end, okay? And whenever you detect that, simple string matching, then you can safely break out of that while loop, okay? Any other questions? Yes?
So if the same client tries to establish another connection, it would get a new socket?
Yep. Yes. Yep.
For receive, when you specify the buffer size, it doesn't have to wait for all that number of bytes to be received. There's only 5 are received when you call it.
Yeah. Totally. Of course. So so the question is, if you receive, let's say, 100 bytes, but your buffer size was 2048, it will still receive it. It will still return the message. I think there was another, yes?
Yes, should the client side give a listening socket?
No. So you don't have to do that, because the listening socket is on the server side just to create a new connections to handle multiple client connections. The client doesn't have to worry about that because it's only connecting to one server. Any other questions? Okay. So netcat. All right, so with netcat, what you can do is you can simply, with a single line, create a server and a client so that they can communicate with each other. Okay? Now let's look simply at an example. Here I will call, it's by the way, it's a command line, Unix command line tool. So if you have Macs, if you have the Linux environment, you can use it. Not sure about the Windows. But for the project, you will have Linux VMs, so you can use this in the VM. So I write nc-l for listen, and I specify the port I want to listen to. Here, nc, I have to specify the server's IP address. Here I know that the server is on my machine, so I can write localhost. And the port, I know that it's 8080. Now I can send messages, and it will appear on the other side, and vice versa. Okay? This, you might ask, why? Because your application that you will write during the project will be in the middle of clients and servers. So you will have to write some code to handle client connections and some code to connect to servers. And if, it's pretty easy to create those dummy clients and servers to debug your code during the project. Okay? If you want to learn more about a command line tool, just type man and then the tool, and you will get a detailed list of everything that you can use for this tool. Okay? Any questions? Okay, so on the command line, you can use other tools to test out those client-server connections. The most popular client-server application protocol is the HTTP. So in HTTP, as you will see next week, you can send GET requests to ask for resources. You can send posts where you may be like sending out your credentials, your username, and your password, whatever. You can do a simple HTTP GET request on the terminal by using wget. So if I do wget google.com, then this will basically download the first page of Google and store it, okay? This is what your browser does as well. It does an HTTP GET request to get the main page, and then whenever you click on something else, it will do another request, which will load another page. You can do wget, you can do curl, which is the same thing, and you can use your web browsers. And that is pretty much what I wanted to cover today. If you have any questions, please do not hesitate. I will post everything on Piazza, lecture plus bits of code. Any questions? All right, yeah.
A little bit overview of our term project.
Sure, okay, great. So the project is going to be a proxy that you will have to write between web browsers and a server. And so the web browsers will try to download video segments, just like YouTube. And your goal is to intercept those queries from the browser. You have to do some throughput measurements. And depending on the throughput of the network, if it's low, then you ask for low quality packets from the server. And then you forward them back to the client so that you can see it. And if it's a high quality throughput, high throughput network, then you can ask for higher quality. You're basically forwarding the request just by changing which quality you want, depending on your measurements at the proxy level. And then when you get an answer back from the server, you'll simply forward it back to the client, which will be the segments of the video, so that the browser will be able to show that video to you. And if you successfully write your end of the code, you will be able to see a video where the bitrate changes depending on the network quality, the throughput quality. Yes?
So the proxy does the measurements itself by issuing out various requests into the network on both sides?
So one thing you can do is whenever you get something from the server or the client, you can have a timer at the beginning, at the end, and then divide the size of the query that you got from the client and divide it by the time that it put the come, and that will give you your throughput. But there will be details on how to measure the throughput, definitely in the project's description. Any other questions? All right. Have a good day.